Hello and welcome again to Microeconomics. Today we're going to continue our discussion of production, and now we're going to switch over from looking at the counts, the physical counts of what's being produced, to the costs that are incurred as a result of that. If you'll remember last time we were talking about production functions and the actual addition of additional variable inputs and looking to see what's happening to the production function. So as we add more and more workers, in our case we're adding more workers who are helping us move furniture and equipment, as we add more and more workers we began to see that we got more and more production up to a point, but at a certain point suddenly we weren't getting any more production. And the reason being, of course, that we had a fixed variable as well. We had a fixed input as well. That is, we only had so big a truck. After a point, we can't load anymore. Doesn't matter how many people we have to load those. And so we had encountered what's known as the law of diminishing marginal returns. We're putting more and more variable inputs into a fixed input. Now, that's a great concept for us to get, but where we're trying to head from here is to actually put that into dollar and cent form. So can we convert that over to dollar and cent form? And that relies on the concept of cost. And remember, we have two different sorts of cost. We have both fixed cost and variable cost. Fixed costs are the cost of fixed resources. They don't change whatever level of output we have. Variable costs change as our level of production changes. So as we add more and more workers, as we add more and more people to help us load our trucks, then the variable cost is going to change. The total cost is equal to the fixed cost plus the variable cost. And as always the case, what we're really interested in is what is happening as we change production levels, how much are costs changing? And it would simply be referred to as marginal cost, which is the change in total cost divided by the change in quantity of output. So as we change from one worker to another worker, what is the additional marginal cost? Now, changes in marginal cost really reflect the changes in marginal productivity. In that section where we saw increasing marginal returns, we should see marginal costs fall. That is, when we have workers who add an additional 5 tons, we should see marginal returns, marginal costs fall. On the other hand, once we've hit that maximum, and diminishing marginal returns begin to happen, that is, the workers who only add 2 or 3 additional tons, then the result of that is marginal cost increases because we're paying all of our workers the same amount. So our job is to figure out exactly where do we want to stop in there in order to receive the maximum amount of profits. Here we have the same mover as before. This is smoother mover. We're renting the truck for $200 a day. And remember that we're employing various different levels of workers, anywhere from 0 to 6 workers. We're paying each worker $100 a day. So you can see in column 4, variable cost goes up as we employ additional workers. So when we have no additional workers, then we have 0 variable cost. As we employ 1, we have 100, 2, we have 200, where that's simply 2 times the 100, 3, we have 300, and so forth. The fixed cost column, column 2, remains the same no matter what. That variable is in fact fixed. It costs us $200 a day to rent the truck, no matter how many tons we move in order to during a particular day. So the total cost will be equal to the combination of the fixed and the variable. So in the case of 0 workers, we have a fixed cost of $200, worker cost of $0, which is our variable cost, so the total cost is equal to $200. In the case of 1 worker, we have $200 of fixed cost, $100 for that worker, so our total cost is equal to $300. And you can figure the rest of those as you go on. Now, we take then and divide that by the change in quantity, and it gives us what the marginal cost is for each additional ton. So as we move from 1 worker to 2 workers as an example, the total cost moves from 300 to 400. The total tonnage moves from 2 to 5. And so our marginal cost, the change in total cost divided by the change in quantity, is $33.33. For the first worker, it cost us $50 per ton. For the second worker, it cost us $33 per ton. For the third worker, it cost us $25 per ton. And then you begin to see it start back up again, which is that point at which we get diminishing marginal returns because marginal cost is increasing. This is kind of the inverse, or the dollar and cent version of what we saw earlier, where we saw that at that point we began to get less additional product. Less additional product, given that the workers are costing us the same each, means that the cost per ton is going up. So we see from that point on, the cost per ton goes up with each additional worker. The result of that is that we get total cost curves that look at something like this. The total cost curve is just the total of both the fixed and the variable cost. Since fixed cost is the same no matter what the output level is, it's kind of the intercept, the point at which the total cost curve begins. And the variable cost curve initially drops, but then it begins to go up. And the reflection of that is what you see in panel B here, where the marginal cost curve, and this reflects the numbers we saw a second ago, where it starts at 50 and then it bottoms out at 25, which is 9 tons per day, and then you see it start back up again. So these two curves actually are comparable in the sense that they have the same inflection point. The inflection point at 9 tons on the total cost curve is the bottom of the marginal cost curve, and it shows you the minimum amount. Now I ask you a question, is that the level we want to produce at? And the answer is, we don't know, because we only know what the costs are. We don't know what the revenues are. And remember that profit is always equal to total revenue minus total cost. This is a typical mistake that's made in business oftentimes, where they're looking for the minimum cost level, but the minimum cost level is not necessarily the same as the maximum profit level. So I'm cautioning you now, don't make a mistake that oftentimes business people do, where they're looking for what's the least cost way of doing things. Least cost way of doing things might not necessarily be the most profitable way of doing things. Now I want to define a couple of additional terms. We are looking to get these on a per unit basis because that's the way we compare cost and revenues. We usually think on a per unit basis, and so a couple of important concepts are average variable cost and average total cost. And we could in fact plot the average variable cost and the average total cost. We'd simply take the total variable cost and divide it by the quantity of output. We could take the total cost and divide it by quantity of output, and we'd get the average total cost. The average here is exactly the same as what it would be if you were figuring your grade. When marginal cost is below the average, then it will actually pull down the average. When marginal cost is above the average, then it will actually pull the average up. And so what we end up with is a kind of a U-shaped average cost curves, which you can see from the numbers here. In column 5 here, we've calculated the average variable cost, which means that we've taken the total variable cost, the number in column 2, and divided it by the quantity of output. So for the very first one, I've taken the total variable cost of 100, divided it by an output of 2, and so the average variable cost is $50. For the next entry, we've taken the 200, divided it by 5, and we've ended up with 40. And more importantly is the column out there marked column 6, where this is average total cost, and we've simply taken the total cost, that is the total of both fixed and variable cost, and divided it by the quantity of output. So we've taken the number from column 3, $300, divided it by 2 and we get $150, and then $400 divided it by 5 and get $80. Now notice on this one that we've left off the fixed cost column, which we included on the earlier one. We don't really need the fixed cost column because we know that it's always $200, that every entry along that, down that column is $200 since it's fixed in amount. And so as a result, it stays the same, and you can simply divide by the Q over there to get average fixed cost. Notice that as long as the marginal cost is less than the average cost, as would be the case in the first one, as an example, the marginal cost is 50, the average total cost is 300, so the next average total cost will be lower. Once the marginal cost is higher than the average total cost, then it will begin to pull it back up again. So if you look at the very last two numbers here, you see that the marginal cost of 50 is greater than the average total cost of 50, and so it begins to pull it back up again. If you draw those, then you get something like this. And notice that the marginal cost curve intersects the bottom of each of the average cost curves. So it pulls the curve downward until it hits the bottom, it intersects with it, and then it begins to pull it up again. The distance between the average total cost and the average variable cost is the average fixed cost. So we didn't even need to draw that curve on here because they're the distance between the two. That is, the distance between the darker line and the lighter line is the average fixed cost, because average total cost is equal to average variable cost plus the average fixed cost. So as that curve wasn't even necessary on the graph because, in fact, it's included in what we've done here. In the long run, however, and this is often the decision-making horizon or the planning horizon, in the long run, however, firms can change their level of fixed cost or their level of fixed inputs as well as their level of variable inputs. So as we think about this particular company, in the long run, ultimately we could begin to employ additional trucks. So we could reach a point where we would think about, well, what would happen if we began to employ more trucks and change the scale of our operation as we change from one to the other. Remember, as we were looking at adding more and more workers, ultimately we got to a point where additional workers weren't terribly useful to us because they could load the truck, but once the truck was full, there wasn't anything they could do at that point. So the next question for us is, what happens if we begin to think, well, maybe we should go ahead and employ all of those workers and hire an additional truck? When that happens, we're now looking at the long run. And the long run is similar to the short run, but not exactly the same. So let's see what happens when we move to the long run. When we move to the long run, we actually end up with a whole array of average cost curves dependent on the scale of plant. And what we discover is that we have economies of scale in long run production, eventually followed by diseconomies of scale. And economies of scale means that the long run average cost curve is actually falling. As we produce more and more, the price, the cost for producing more and more actually falls. Eventually, however, it will begin to turn back up again. That is, as we begin to think, well, if we add a second truck, could we lower cost by adding a second truck? And the answer is yes, we could. Ultimately, however, we would reach a point where we had so many trucks that our cost would begin to go up again. The first section is known as economies of scale, and the second section is known as diseconomies of scale. So we would see Here's the case where we're contemplating 3 different levels of operation, and we would see that at least to begin with, as we changed levels of operation, which in this case means change number of trucks or change the size of the warehouse or something of that sort, as we change, to begin with, we would see a drop or economies of scale, but ultimately we end up with diseconomies of scale. So we actually end up with a whole array of potential size plants. We could actually make various different plant sizes. And you might want to think in terms of the example that we've been using. ATC1 is only a single truck, ATC2 is 2 trucks, and ATC3 is 3 trucks, and so forth. So we could consider changing the size or scale of the plant, each one of which has its own average total cost curve. And we would see that at least initially cost would drop, but then ultimately cost would begin to go back up again. So from the long run standpoint, we would see actually 3 different categories or 3 different areas. First, we would see economies of scale, which means as we increase output or change the size of the plant, then cost actually goes down. Then we would see a segment in which we have constant average cost. As we increase the size of output or the quantity of production, costs don't change, but ultimately we would end up with diseconomies of scale, which means that increasing the quantity of output would ultimately drive average cost up again. It's probably easier at this standpoint to think in terms of what happens with an actual physical plant rather than a whole array of trucks. And what actually happens with the whole with the actual physical plant is we could change the size of the plant. We could change from making 100,000 units per year to making 200,000 units per year to making 300,000 units per year. From the standpoint of the firm level, the firm could actually change by changing and adding additional plants. So once that plant reaches its maximum, say 250,000, then we could have an additional plant which would allow us to increase our output. So the moral of all of this is that in the long run, we actually can affect that cost curve, and we can find ways to get around the law of diminishing marginal returns. What it requires is that we vary the fixed input, because remember, the law of diminishing marginal returns says that as we add more and more variable input to a fixed input, eventually the cost goes up. Well, the solution to that is to simply change the scale of the plant or change the size of the fixed input, which you can do in the long run, but you can't do in the short run. Okay, we're almost there. The next thing is to figure out how we can put the cost of these together with what they're returning to us, and then we'll be in a position to say, okay, this is the right number of people to employ, or this is the right amount of equipment to employ, or whatever our variable input might be. That's it for this time. We'll stop here and we'll see you next time.